Ladies and gentlemen, welcome to Jani.tv. Today's segment is The Encounter. And I have a very special guest, Aparna, with whom I have worked at Google. She comes with diverse experience of working at various Silicon Valley companies, and currently she is one of the investors primarily focused on generative AI. Aparna, it's an honor to have you on my show.
Hi, Jani. It's great to be here. Thank you for inviting me.
Awesome. So, Aparna, I worked with you when you were heading GKE and rest of developer tools at Google, and now you are an independent VC, working with a lot of next generation startups. So, it's a very interesting journey. So, why don't we get started with your background, your journey from India to Silicon Valley via Stanford, Google to where you are?
Sure. Yeah, I'd be happy to share with your listeners. Right. So I was born in Delhi, and I grew up there through high school. I did have, parents with traveling jobs. So during my middle school, we traveled to San Francisco, and I lived in San Francisco for a few years, which is why I don't have much of an accent. But then we went back, and I've completed my high school from Delhi. Actually not traveled much within India, really been based in Delhi the entire time, but really benefited from the Indian education system. Excellent mathematics, excellent science curriculum, especially in the high school. And then, actually, I was going to go to engineering college in Delhi as well. I was admitted and had started actually, but then my college went on strike, and one of my friends was applying to the US for colleges. And because we were on strike, I thought, okay, let me go ahead and apply as well. And as it turns out, I got a really great offer with full scholarship from a few different universities, the best of which was, of course, Stanford. It was not planned, but since it was such a good offer, my parents decided to send me here, and that the rest is history. I did my undergraduate in physics, which is what I had always wanted to do. I'd wanted to be a professor of physics, but being in Silicon Valley, I was bit by the industrial bug, and especially in those days, it was the .com era, and I started to take a computer architecture course at the time in the electrical engineering department with John Hennessy. And I was so amazed by how computers work and how everything that I had wanted to learn about physics, how it comes together in service of building something as powerful as a computer. And then I decided to switch gears, and I did my co-term or master's in electrical engineering, and then also my PhD in electrical engineering. So that's my educational path.
Fantastic. So, how did you make it to Google?
Sure. Well, when you are doing your undergraduate at Stanford, especially at that time, many of my friends, were recruited to Google, and it was certainly one of the most exciting options. And in fact, I didn't join Google at that time, which is what it is, because I wanted to do more research, and so I decided to do my PhD. And ultimately, my path to Google was actually quite a windy path. Um, I was not a big believer in ads, so this was the reason why I chose not to join Google, during the early 2000s, because I thought this is like a consumer and ads company, and I wanted to work on, building systems for large scale enterprises. This is what I thought at the time was the most important thing to do as an electrical engineer. I actually joined McKinsey and Company after my PhD. They were hiring PhDs to work in the technology field, in the IT field, and that is where I think I found my platform. I joined the IT team within McKinsey in Palo Alto, and we served mostly CIOs and software companies. At the time, Software as a service was very new. Cloud computing was not even really heard of at the time. And so I co-founded the cloud computing and software as a service practices within McKinsey's Palo Alto office and did some of the knowledge work in that area to determine, what is the impact of software as a service? And then over the years, what is cloud computing? What is platform as a service and infrastructure as a service? So we came up with some of that terminology along with others in the field. And my clients at the time were running their applications on dedicated servers, and server virtualization was very new. So a lot of the projects that I did were helping our clients move from dedicated servers to virtualized servers, which was really exciting actually, just because of the efficiencies that could be gained, and the overall impact it had on teams and the operations inside the data center. So that was my work. And after 5 years at McKinsey, I went to NetApp to lead their private cloud management software division. Many of my customers, after having virtualized, were struggling with really how do they manage their on-prem infrastructure as a cloud. So that was the whole notion of implementing private cloud. And at NetApp, I worked very closely with VMware, did a lot of integrations between VMware, Microsoft, Oracle, and NetApp. So kind of working up and down the stack. And at that point, 3 years into NetApp, I realized that storage was really getting commoditized by the cloud computing players. And at that point, Google had just started having a cloud offering. And so that's when I moved to Google. I had always, of course, had great regard for Google as a company. It's a fantastic and amazing company, but it didn't have really much of an enterprise offering, even when I joined. And that was really my expertise. So the time was right. I think I joined Google in 2013. So that's when I moved over. In fact, I remember going to a NetApp EBC and talking to my customers about buying NetApp gear, and they were actually using Google Cloud storage in Google Cloud, and so that's how it came to my attention. Oh, actually, this is probably the next generation, and it was irrefutable. The economics were so much better of using storage in the cloud than buying storage hardware, and storage hardware didn't really scale out the way that cloud storage did. So that kind of prompted me to move to Google. And I've been at Google for the last 10 years, doing a variety of different things. I started by I started building an internal CRM system. So not cloud, but really kind of an internal CRM system. This is the system that runs support for Google. And so when you call Google with a problem with your Android phone or your Chromebook, this is the system that you would be encountering. And it was really exciting because as a technical person joining Google, it's like going to Disneyland, really, because there's so many new tools and technologies. And so even though we were building a CRM system back in the day, there were a number of new machine learning capabilities that we applied to the CRM system. So we did things like feedback clustering with the feedback that you send from your Android device. We did things like we built a chatbot for the support agents to help them answer calls or answer emails. We did sentiment analysis on the emails themselves, as well as on the calls. So, these were not capabilities that were available outside Google at the time. So it was a very exciting journey. And then from there, I moved to the Android platform team. I had always wanted to work more on the operating system side, and we worked on the Internet of Things at Google. And then ultimately, there was this new project that was just starting. It was an open source project. There wasn't much of a team, and it was a very uncertain project. And they were looking for somebody to lead product. And I saw a lot of parallels. First of all, it was an operating system, but it was an operating system for the world, for the cloud, and not just for Google internally. Of course, there's a way that we do things at Google internally at the time. This was a way to take that knowledge and bring it to the enterprise. And it also had a lot of parallels between the work that I had done in server virtualization, kind of making things more efficient, and really kind of enabling that private cloud promise that had sort of not been completely fulfilled with the VMware NetApp work that I had been doing. So I really gravitated towards this. And I reached out and I met with two folks. I met with Brian Grant and Tim Hawkin, and they interviewed me. And they were like, yeah, okay, they were so stressed at the time, I remember, because they were working like 24 hours, 7 days a week. They could hardly find time to even interview me. But anyway, it worked out, and I joined Kubernetes, and it actually turned out to be a rocket ship. And we really kind of built GKE together, built the business, and yeah, and then I moved on to developer productivity and serverless containers. These were sort of the next generation. I've always liked to work a little bit ahead of the game, work on the next generation of technology, and that's also what took me to now. I'm at Pair VC, and I'm leading up the AI investments along with developer tools and cloud. They're actually quite related. And I think that this is the next generation as well. So I like to be a little bit ahead of the game so that we can help shape what happens next.
Fantastic. Wonderful experience, and thanks for sharing the journey. So, Aparna, I remember meeting you when GKE was just getting launched, till one of the last briefings that I had with you when you launched Anthos and even Anthos Bare Metal. So, I always heard from you when you're presenting passionately to analysts and doing one-on-one briefings. So, being a fan of Kubernetes and cloud native, it was always fascinating to hear your side of story and how you actually presented Google's big picture and vision to the analysts. So, uh, what was it like building the world's first managed Kubernetes service? And I know Google was obviously the first one to bring managed Kubernetes to the hyperscaler environment. So did you collaborate with the original founders, the trio of Joe Beda, Craig McLachie, and Brandon Burns? How was that experience?
Yes, I think the experience of bringing GKE to market and building it into the first and I believe the most effective managed Kubernetes service. I think it was kind of that 0 to 1 founding experience. And then after that, building, the hybrid offering as well, very much, kind of the founding experience there. Um, my belief, I think Kubernetes, it has two prongs. It has the open source, the community piece, the piece where we do co-development with many other players that are serving different parts of the ecosystem. I think that is very important. And actually, that's where I started. When I started on the Kubernetes team, I started with the open source. And given my storage background, I started with the storage interface. But I was always convinced that in order to make an open source project sustainable, it is extremely important that we have a commercial offering, and that commercial offering should be an area of focus for our team. And that we should be working very closely with our customers. There were a few reasons for this, and I would say that one of my contributions to certainly Google and Kubernetes is bringing that commercial focus along with and marrying it alongside with our open source leadership. This is kind of a difficult thing to do in some sense, but it's really important, and I can talk more about why I think it's important. For an open source project, especially for the core maintainers, for the ones that are have generated that project, it's extremely important that they also have close connection to that project in production with customers. You learn a different set of things when you're working with customers who are running mission critical applications on your software, and that informs your roadmap and how you develop that roadmap. I think it's extremely important. My experience working with CIOs inside enterprises during my McKinsey days and also NetApp days, it really taught me the importance of being close to customers. It's also something that I enjoy very, very much. And so it's one thing to be working with the leading edge of developers in the open source. It's also very important and it teaches you something else. But it's another thing and a very important thing to work with paying customers who are giving you money, and their their own livelihood is dependent on your software. So we learned a lot, and they would file bugs against GKE, and we would learn from those bugs. We would of course improve GKE, but we would also upstream the capabilities into Kubernetes. So it was a really virtuous flywheel, both for the open source as well as for us commercially. And we built that into a highly commercially viable project. Some of the things that we did, we improved the usability. We created a really nice dashboard. We made it possible to start clusters in less than 5 minutes. And we continued to work on that goal, reducing it to 3 minutes and 2 minutes. We, kind of learned from our customers what was important in terms of moving from digital natives to enterprises, really improving the storage interface, really improving and bringing in the RBAC capabilities, and improving the security. A lot of the questions that our enterprise customers had on GKE in the initial days were around container security and what are the capabilities that you can offer us there. So it really shaped our roadmap. And ultimately, we built GKE into an SLA backed service. We added scalability to it, so it's much more scalable than other managed services. And indeed, you're right, it was the first managed service, and I think it was for some time the only managed service, at least a cloud managed service. The other advantage we had was that we did operate in the cloud, and so our customers were always live, and they were always, their usage was always giving us feedback, and we could actually monitor what was happening to an extent. We can't look inside a customer's environment, but at a high level we could see what kind of operating system is being used, where are the bugs, is it the node, is it the networking, where are the problems, what are the types of problems that people are having. So we learned a lot from that, and I think it made both our product better as well as the open source project better. And then with regard to where,
Absolutely.
yes, go. You asked a question about the origins of Kubernetes. The origins of Kubernetes are very much from Borg inside Google. And so I would say that I worked very, very closely with the originating team, because I think of the originating team as the original Borg team that then split off to work on Kubernetes. And Brian Grant and Tim Hawkin, folks like Don Chen, and David Oppenheimer, uh, 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 and Daniel Smith. These are folks that originally worked on various different aspects of Borg. So Dawn Chen, for example, she was responsible for the node, for the operating system interface, for the Docker interface, for the container runtime. This was very, very important in the beginnings when we were trying to set standards. And then, David Oppenheimer, he was responsible for the scheduler, and for all of the innovations. When I started, it was a very basic scheduler, and then we worked through so many new capabilities, like they have very interesting names, forgiveness and affinity, and adding custom schedulers. And we also had the scaling team in Warsaw. These were all with Wojtek. These are folks that have been, and with Daniel Smith, the API servers. Think about, we had third-party resource, then custom resource definitions, and that has become a whole thing of its own. So I believe that I worked with the founding team of Kubernetes over many years to actually bring out those pieces of Kubernetes that were reimagined from Borg in the context of our enterprise customers, and that was very much a co-development and really kind of an invention, I think, of what Kubernetes is today, and of course what GK is today. I did also overlap
Absolutely.
a little bit with Craig McLuckie, for sure, and also with Brendan Burns, but they were not working on Kubernetes at the time when we overlapped. That they were working on other areas of Google Cloud.
Got it. Got it. Excellent. So I remember, using Google Kubernetes engine when it was still called Container Engine, and the only way of interacting with that was through the G Cloud SDK. So, from there to where it is today with Autopilot and Anthos Hub and fleet management, it has grown significantly, both in terms of functionality and complexity. So, Aparna, this is something that I want to ask an ex-Googler, particularly who comes from the Kubernetes background. I'm sure you read the "We Don't Have a Moat" leaked document, that talks about open source versus commercial LLMs. I'm going to touch upon that towards the later part of this discussion. But in hindsight, do you think it was wise for Kubernetes to open source Kubernetes and donate it to Linux Foundation to form CNCF? What kind of implications it created, and how do you see that getting applied to the current context of generative AI?
Yes, Jani, I think, I am very clear on this topic. I've gotten this question many times and people have asked this question. I'm very clear on this topic. It was a very good idea to open source Kubernetes. And for that, I do give credit to, I think Craig McCluskey and Brendan Burns, I think they had and Joe Beda, they had a real kind of impact there in open sourcing this technology. I think it was important from a few different angles. I would say three different angles. Number one, it was really important for the dissemination of this technology and the wide adoption of this technology. So I would say from the point of view of the users and the customers, this is a net benefit, a net plus for Kubernetes to be open sourced and for there to be an open source foundation like the Cloud Native Computing Foundation. What it does is that it gives it a level of longevity, but more importantly, it gives it broad adoption around the world and across many different organizations, which may not all have the same commercial purpose. So that means that we can actually, with Kubernetes, reach many more segments. So, for example, of course, we can. In the early days, Google was very focused on the digital native segment. So, customers like Spotify or the more digital native kind of internet forward ones. On Amazon it's like Pinterest at the time and Uber,
Khan
etc.
Academy, which is Snapchat, one of the the standard case studies that Google would always talk about.
Right. So at the time it was that, but because Kubernetes was open source, we also had Red Hat involved as a very high contribution party, and they were highly focused on enterprises, traditional enterprises, so Barclays and other banks and financial services institutions, and so that rounded out the roadmap for Kubernetes, and it was actually the harbinger of some of the future capabilities that Google Cloud would also want to offer. Because in Google Cloud, we started with digital natives and then we moved into enterprise as well. We sort of expanded that customer segment. So because of that open source collaboration, I think Kubernetes developed faster and was a more well-rounded project. And also you see Kubernetes being used on edge devices, and that's again like smaller devices, and that's also something that came out of the open source community. So I think for users, and now you see, and this is something that I encouraged as the chair of the CNCF governing board for quite some time, is a real focus on the end user board. So you have folks like Apple and Spotify that have contributed many things back to Kubernetes. Sometimes they're at a higher level, higher layer, like Backstage, for example. But that's very useful to the overall longevity of Kubernetes. So that's number one, is good for the users. Number two, it's good for the project itself, because it has more diversity, it has more adoption. That means that we get a lot more adoption and growth in different areas of Kubernetes. And then lastly, I think it is very good for Google. It was very good for Google to have open sourced it on several levels. Number one, the engineering and product teams got an opportunity to participate in open source and really work with developers at a very early stage. Before we had customers, we had users who were giving us feedback on the Slack channel, etc. Also, I think it was good for us because it really gave us a platform from which we could develop a hybrid and multi-cloud offering, right? Because it was adopted beyond us. It does have trade-offs. Making something open source has trade-offs. It means that you are working on something that your competitors and others could use and benefit from your engineering. And so that is a problem with open source, and it's not just a problem with Kubernetes, it's a problem with open source in general, that I think the industry as a whole has been working on, with better licensing models, with open core kind of framework of running open source technologies. And of course, cloud has made it much more viable to build and run open source and actually profit from it. I think it's extremely important to have a sustainable open source project on which you are able to generate a profit if you're going to be maintainers and contributors. So that's something that we had to learn over the years of Kubernetes, but I think we did it effectively.
Absolutely. Today looking at the CNCF, the landscape and how many companies are a part of that community, it's just amazing. I still remember attending the very first KubeCon, which was in one of the hotels in San Francisco. It was just like a meetup. I think there were like handful of folks who were presenting, and Kelsey was one of them, who actually was very, very bullish about Kubernetes. And to the most recent KubeCon in Amsterdam, the growth has been just exponential. So, Aparna, that brings me to the next question. So, if you look at the Kubernetes distribution ecosystem, it has kind of settled. It has reached a level of stability that customers can now filter options into, for example, OpenShift, Tanzu, Rancher, and there are just a handful of them, and it has kind of stabilized. Now, on the other side, when we look at the public cloud, there has been a proliferation of non-Kubernetes based container runtimes, like Cloud Run, for example, which has been your baby for a while, and ECS Fargate and Azure Container Apps, Azure Container Instances. Now, none of them are Kubernetes compliant, none of them expose or understand Kubernetes API, but they can pretty much run containers. So one of the concerns I personally have, and I hear this from the community as well, is why is there no standard for platforms, and why are the platforms, particularly on the public cloud, getting fragmented?
Yeah, I think there's a couple of things at play. One is that users need simplicity, especially application developers, and teams that don't have a huge platform team. They need simplicity, and for that, there were always things like Heroku, right, where you can get started quickly, and that has a ton of value. And now we have things like Vercel, and of course Cloud Run, which, like you mentioned, was my baby. I actually moved to work on Cloud Run. I was very passionate about it because of my Kubernetes experience. I think Kubernetes is extremely powerful, and one of the things that we did as the Kubernetes team, I would say also partly my contribution in setting the roadmap, was expanding Kubernetes from being just web applications to being many different types of applications, to being able to run databases and stateful workloads and machine learning workloads. One of the things we worked on, right, was adding automated GPU scheduling. And this is something that GKE in particular excels at, because we invested very consciously on, okay, it should not just be web applications. This needs to be a platform that's very, very broad. And over time we have been expanding it still, kind of adding more types of accelerators, different types of storage, and different types of workloads.
Like, Kubeflow is completely based on that. Without that, Kubeflow wouldn't just work.
Right, exactly. So, but there's also the risk that the project will fragment. And, this is something that happened to OpenStack. Again, thinking back to my days at NetApp, we weren't really able to, as an industry, have a private cloud standard. There's so many different ways of doing it, and there was open source, and it wasn't very simple to use. And ultimately, it sort of fell apart, right? There was no way to really do a good private cloud. Now, I think Kubernetes has that chance to be that private cloud. And from what I see, lately, Gartner, I think, had a report that said that 90+% of enterprises are experimenting or using Kubernetes in some form. I would say that Kubernetes has really arrived as a standard in the enterprise. Everyone I speak to is using it at that layer, whether it's machine learning or it's some other workload. And we I think that we had a role to play in that, not just the developing the roadmap, but because we worked on this aspect of Kubernetes, which is called the certification, conformance program. And Google actually contributed a huge amount. I had a product team and an engineering team that was working specifically for a year on defining what it means to be Kubernetes compliant, what it means to be conformant with Kubernetes. And there are a set of tests that we wrote and we worked with the community to write, that you can run to say that this is actually, this distribution is actually adhering to the specification of the Kubernetes API as a whole. And that specification and that set of tests is something that you then have to pass and submit to the CNCF to have the Kubernetes trademark, and the CNCF actually monitors that, right? So that's something I worked very closely with Jim Zemlin, Linux Foundation executive chair, on. He was a sponsor, and we worked very closely with Brian Grant and the API SIG to help define this conformance. But what that also meant is that Kubernetes is kind of this closed box. It's this layer, and then if you want to build something on top of it, like let's say you want to build a better developer experience, or you want to build, something like Cloud Run or something that's more akin to Heroku, you have all these CI/CD capabilities that you want to integrate. That's not Kubernetes. That's actually a layer above Kubernetes. And so that's by design. The layer above Kubernetes is sort of not defined by Kubernetes. It is, we've kind of said what Kubernetes is, and it ends there. And so that is I think that has pros and cons. The pro me is that it gets to be a standard at that layer, which I think is a good win. It doesn't get fragmented. It doesn't become OpenStack, right? I think that's a good win, and it's worth the trade-off that there is no definition really above Kubernetes, and so there are 1,000 flowers that can bloom at that layer, and that is the case. And unfortunately, what that means is that it's not super simple to run applications and manage applications on top of Kubernetes. And so you have folks building things like Backstage. You have people, working on Knative. We worked on Knative. You have the simplicity of some of the other serverless container runtimes. And I think that's by design. What I think will happen, and so I was very, very passionate about Cloud Run, because I think that it provides a level of simplicity that our customers needed, especially when they're starting out, right? But these container runtimes like Cloud Run are not as flexible. They cannot run as many different types of applications as the Kubernetes platform. So there's a trade-off there. If you have a team that is a little bit more platform oriented, they can build something on top of Kubernetes, either using Knative or using some of these other capabilities. They can build something on top which is customized. It's a customized platform for you, for your organization. We found, at least at the time, that there were so many different requirements in terms of what an enterprise wanted from a platform, that there wasn't kind of one solution for all the different types of applications. We started with Cloud Run, and with Cloud Run, our goal was to, again, just like we did with Kubernetes, expand the number of applications that Cloud Run could support. And I believe we're still on that journey. Like Cloud Run, for example, doesn't have great support for GPUs yet, but that's something that's coming. The other thing that I think will happen is not conformance with, but the ability to interoperate with the Kubernetes API, which is right now missing. But I think that is something that certainly we should be working on within Google, and hopefully other companies as well, because there are so many benefits to running on Kubernetes, and then there are benefits to running on getting started on some of these other serverless container platforms. And if we could have the best of both worlds, I think that would be much better. And so that's something I think will happen over time.
Absolutely, and that's a great cue for my next question. So, complexity of Kubernetes. No one wants to deal with the cluster infrastructure, setting up Kubernetes. That's the reason why people find it easy to get started with Cloud Run or ECS Fargate. But do you think platform engineering is an answer to handling the complexity of Kubernetes? What's your one-liner view about platform engineering, and how do you see that?
Yes, platform engineering is an extremely important role, but I think the complexity of Kubernetes has been reduced significantly. By the way, we've worked on it for a number of years. It is a very flexible system, and because it's a flexible system, there is complexity that is associated with it because of that flexibility. However, if you do not need that flexibility, you do not have to really kind of immerse yourself in the complexity. There are many more simplified capabilities that have been standardized, and I pointed to one, GKE Autopilot. GKE Autopilot is a service that simplifies a lot of things. That we have 4 different types of auto scaling within Kubernetes, and it's great if you are a platform person and you enjoy learning about those different capabilities, and you want to sort of fine tune each of those capabilities to your workload. You do get value out of that. But if you're a small team and you're just trying to run an application, and what's important to you is time to market, then you may want to use something that is is already makes those decisions for you. And that's what we try to do with GKE Autopilot. Really already made those decisions for you. Auto upgrades, auto repairs, auto scaling, all fully sort of nailed down. We make a lot of those choices, and that makes it easier. In terms of the platform team needs to do less. But I do think that in large enterprises, there are, custom requirements. So right now, I'm working with a few large enterprises that are running machine learning on Kubernetes, and there's a lot of customization and tuning.
Right.
So then it's good. It's good to have that. I mean, I know you call it complexity, but it's good to have that flexibility.
Right. No, GKE and GKE Autopilot, I have no doubts. It simplified significantly. But my experience is when customers are running Kubernetes on-prem and when they have to handpick the entire stack, all the layers of the stack by themselves, it turns to be extremely complex. And of course, Anthos on bare metal and some of those initiatives are trying to reduce the complexity and pain, but it is still not easy. We'll come back to that maybe as a follow-up discussion, but I have more interesting questions lined up for you, Aparna. So switching gears, I have been seeing your contribution and being very active in the Gen AI community, the generative AI community. So one question that is lingering in the minds of everyone who is involved in this and watching this transition from the deep learning to the generative AI, is this whole new battle between proprietary black box opaque Gen AI models versus open source LLMs. So what's your view on that, and particularly applying your context of working with NetApp, Google, and having been in the forefront of open sourcing Kubernetes? How do you see this whole thing?
Yeah, so just in terms of my context, I joined Pair VC last year in November to work on, our enterprise investments. So Pair VC is a very broad investment firm. It's the leading seed, pre-seed stage investment firm in the country, and it has one of the largest pre-seed seed stage funds. It's a $400 million fund that we are investing out of. By the way, you were talking about that excitement going to the first KubeCon. I get to experience that excitement on a near daily basis with the startups that I work with. So this is why I moved. But when I moved, it wasn't clear that I would spend so much time on AI. I had actually thought that I would have a lot of DevOps. At the time, I was working on secure software supply chain and DevOps, and I thought I would have a lot of companies, startups that would be doing work in that area. And it's true, there's some. But what happened in October of last year or November of last year is that OpenAI came out with ChatGPT, and suddenly that interface, changed the level of adoption, amongst the general audience of generative AI. And that's because I think they did a few things right by doing that RLHF, reinforcement learning with human feedback, by really aligning their model to what humans would accept in terms of conversation. And I think as they ran ChatGPT, they really took a lot of feedback from those conversations and incorporated it back into the model, making it better. And that was the sort of the opening of the Pandora's box, where it became clear that actually, AI is capable of a lot more than what the world thought it was capable of. And just to go back to my experience at Google when I started in 2013, remember I was building chatbots, and my team was working on feedback clustering and sentiment analysis back in the day, right? So these technologies are actually, they've been in progress. People have been working on them inside companies like Facebook and Google and also Microsoft for a number of years, and of course OpenAI. So these capabilities have been around, but the unlock of really making them available in a way that they could generate either code or text or conversation, that they could generate those things in a safe way that was accurate enough to be consumed. This is a work in progress still. It's not done. It's a work in progress. But there was a breakthrough that happened. And it was a breakthrough that wasn't just a contribution of OpenAI. And maybe not everybody realizes that. That breakthrough has come through really actually open contributions that many folks have made, both in the open source as well as from a research perspective. A lot of work was done at Google and then contributed through research papers. A lot of work was done at DeepMind. This idea of RLHF is something that the folks at DeepMind worked on. The underlying technology of transformers is something that came out of Google and Stanford together, but really a major contribution from Google. Google open sourced this initial model called BERT, which is sort of the initial model that had a lot of these technologies. And then, of course, OpenAI at the time was also more of an open organization in terms of research contributions. The GPT models so generative, pre-trained transformer, which is just taking the decoder part of the transformer and then using it to generate text and language. That is something that they published quite openly for GPT-1, 2, and even GPT-3, kind of how did they train the model? What is the data set that they use? A lot of the data sets are open data sets. So this capability didn't come out of, closed research. It came out of the contributions of many. So I think going forward, I believe that it's important to maintain that. I think it's important for there to be sharing of the findings, because this technology is so impactful. It is going to have just, again, thinking back to year 2000 when I was, at Stanford, the effect of, the web technologies at the time, you saw it really kind of play out over the next 5 years. And big companies like Google were founded, as a result of some of the developments. And of course, Google contributed a lot of those developments. Not all of those developments came out into the open right away. It takes many years for some of those developments to come out into the open. Like Kubernetes, for example, we worked on Borg, but it was many years later that we contributed. So I do understand the commercial impetus. I do understand why OpenAI sort of closed, their GPT-4 model. This is so advanced. And, a lot of investment went into developing something like GPT-4. And I understand kind of, what Google is doing with Palm and so on. So there are commercial objectives involved. And so it's not 100% open source. But, companies like Meta and Hugging Face and also the folks at Stanford. I'm collaborating very closely with the folks at Stanford right now. They are bringing out open source alternatives, and there's a whole research movement that's happening. It's important. It's important because customers and users want to be able to introspect the software to understand, well, what went into this software. And it's also important for the further development of the field itself. It's important for next generation of researchers to be able to build upon what was done previously, for us to know, okay, how exactly did this RLHF work? What was the data set that was involved in training some of these large language models? So to the extent that that can be shared over time, even by these commercial entities, I think it will benefit. But in the meantime, many other folks, including at the Linux Foundation, are working on, kind of making these data sets open and putting a level of reliability against them, making sure that it's legal and it's regulated to be able to use this data in training these models. And then again, I always believe that it's important for mainstream enterprise adoption, and for mainstream enterprise adoption, it's important that these models be able to be used in a private context, so that an enterprise can take a model and run it inside its own data center, potentially on-prem, or in the cloud inside its own VPC, and to be able to fine-tune and retrain that model with its own proprietary data without feeding that data into some sort of central service. So that's going to enable use cases in healthcare, in law, in enterprises in financial services who need that level of privacy and assurance. And then That's where I think these open source models really come into play. So there are techniques right now in development where you can take an open source model, which is a much smaller model, can be put into your private environment and fine tune it on your data and get it to run reasonably well. Maybe not, at general tasks as well as GPT-4, but at your specific tasks, whether it's, in a healthcare setting or in a legal setting to provide advice to the lawyer or to provide, advice to the doctor, to really kind of make them more productive, take out a lot of the grunt work from some of these jobs. That is something that is going to be based on open source models, and those open source models are going to get more effective because of the commercial flywheel here.
Right, right. But at least as on date, when we look at the big picture of LLMs, the battle, the battle lines are very clearly drawn. On one side, we are seeing Azure OpenAI, Microsoft plus OpenAI combination, and then Google's Palm 2, which is again very proprietary. They are exposing that just through the API, and then Amazon is all set to launch Bedrock and Titan, a set of their own foundation models. That is on one side. The other side, we are seeing Meta's Llama, which comes with the GNU, if I'm not wrong. And then the variations or the flavors of Llama are coming from, for example, Stanford's Alpaca, and Berkeley's Vicuna. Uh, some of the Llama based models. So that is the entire open source. But again, the licensing restrictions are preventing from commercializing, or at least using these models in a commercial environment. So anyone who is looking at embedding or infusing Gen AI into their product will have to fall back to the API model and consume it from the hyperscalers. Uh, that is what is concerning, because today we don't have a very clear mechanism on how to consume open source to build production grade commercial applications.
Yeah, I don't think it's quite like that, Jani. So, yes, the OpenAI and Google models are proprietary and closed. Although they've published some basic papers, but yeah, they're closed. The Llama model from Meta has a restrictive license, which is for research only. However, the work from the Alpaca team, and then there's another team called Red Pajama, that has been working on open sourcing the data set that was used to train Llama, and also creating a version of Llama that is not restrictive, that is available for commercial use. And they've already put that out there. So it's available now.
Okay.
So the Llama model effectively is available for commercial use now. And there are a previous generation of open source models, several of them, BERT and BART and,
Roberta.
various. Yes, there's a number of different models. There are less, actually. Hugging Face has put out a few models as well, Bloom and then Hugging GPT. They are less capable on a general level than GPT or Palm. So if
Right.
you're going to ask it anything under the sun and you want it to have a conversation, these models are less capable of doing that. But the more generalized models like GPT-4 and Palm also have much higher level of hallucination. Like they will make stuff up, right? I think over the weekend I was asking Bard, hey, who's the founder of Stability, and who did the funding in Stability? And then I asked it, about Bard itself. I said, is Bard available, widely available? And Bard said, Bard is not widely available. It's in private beta, but Stability AI will make it available in the future. So it takes the context and it convolutes it and it gives you some hallucinated answer. So this is like a state of the art large language model today, right? Like this is with the Palm 2 API. And same thing, I asked GPT-4 the same question, and it's not aware of Bard. It's because its training cutoff is in 2021. It has no idea. And the plugins, even though there is a web searching plugin, the plugin is so slow that it kind of actually fails
Right.
to in fact do the job. So there are, even though these large models are very capable of answering general questions, they do have significant problems for enterprise use, right? They have
Right.
significant problems, even though yes, maybe, um, aside from the fact that they're hosted only in the cloud, and it requires an API, and maybe it doesn't provide all of the privacy safeguards, although both Azure and I think Google and AWS are working on, ways that you can take these models, containerize them, take them to SageMaker or Vertex AI and fine tune them, and then run them in your own VPC. And they're not collecting your data to retune these models. So they are providing a level of enterprise friendliness over time. But our thesis at Pair, and this is something that I've worked with the team to create over the last 6 months that I've been at Pair, is that for enterprise use cases, you're not going to want these really large foundation models.
Hallucinations. Yeah.
Well, you certainly are going to want to eliminate hallucinations, because think about in the patient setting or in the legal setting, you know it would be so disruptive to have wrong information that's made up. Like, you say, oh, this disease, this patient has this disease, and they don't actually have that disease. Like, that is very, very damaging, right? Same thing so in finance, or in investing. So the architecture that's emerging for how AI based applications are developed is twofold. One, it involves a layer of retrieval systems. So there are databases, vector databases, into which you take your input data, the data that you're working off of, and you retrieve that you convert it to embeddings, which is a much more compressed format, and you store it into a vector database. And then you use your query, and depending on what the query is, you use that database. So this is called retrieval augmentation. And through that process, for information on which you need a high level of accuracy, you can actually get not only the accuracy and prevent hallucinations, but you can also know what source was responsible for the answer that you got. So it's not some generalized answer, but you know exactly where the answer came from. And the large language model in this case, is being used more for conversation, more for taking the text, maybe summarizing the text, and having the conversation both on the input side and the output side with the user. And for that, you don't really need a model the size of GPT-4 or of Palm 2. You actually can take one of these open source smaller models, maybe even BERT or BART or Llama, which is now the more modern, version. You can take that and you can fine tune it towards your specific use case. If it's, medical language or it's legal language, you can fine tune it towards that, and then exercise it on your proprietary data, which is the data that is involved in the medical field or the legal field, and is maybe even specific to your hospital system, to your patients. And that's kind of how it's going to be used in the enterprise. And these open source models have so much more validity, because this architecture that goes underneath them can make it possible for it to be conversational, but at the same time accurate, does not hallucinate. It's available in the private, in your private data center or private cloud, and it's fine tuned to your data. So I think that is a much more effective way for large enterprise adoption.
Absolutely. I think the scenario and the use case that you explained will drive much more broader adoption of vector databases. We are already seeing a lot of investments flowing into companies like Pinecone, Chroma, and even Redis is becoming the most preferred vector database for embeddings and search. So definitely, I think the way you explained this, it's put very well. You don't need the models of size of GPT-4, but you can take a smaller one and either use contextual prompt injection based on vector database or fine tune it, and that becomes much more manageable and brings us to the edge and hybrid environments.
Yes, I mean, fine tuning on your data with open source models is a very effective technique, and augmenting that with a retrieval system, and a search index on top of that, it's a very effective technique for enterprise use cases, and I'm seeing it used widely. There's still a place for the large language models. I think the large language models, that are proprietary, they'll be more useful in sort of more consumer applications, and there are many other areas, there's this notion of, like, personalized agents that uh, talk to you, or help you with various aspects of your work life or your personal life. This is something which requires much more empathy and much more kind of conversational capability. And this is an
Yeah.
area where some of these models can be used.
Project Tailwind that Google just announced is one of those. It basically crawls your Google Drive and learns from your documents in a very private form, and then talks to you based on that context. So almost very similar to the scenario that you explained. So Aparna, we are almost out of the time, but one final question that's highly relevant, and I cannot end this interview without asking you this. So both of us come from cloud native environment, and now we are looking at LLMs purely from a technology perspective and the excitement around it. Where do you see cloud native and LLM meet? What is that inflection point where cloud native can take advantage of LLMs?
I think there's a couple of places. One, which I've been, kind of what led me into this is, as I was mentioning, I came from Kubernetes, and then I felt like the Kubernetes problem had been largely solved, like we established it into a standard, and the next level was really kind of improving the developer experience. So I was very focused in my last 3 years at Google. I was very focused on developer experience, and one of the things that I was looking at, and I think is extremely important, is using machine learning to automate this process of writing code, and actually improve the developer productivity overall. Really kind of, I think, well, I mean, there's no question Microsoft is the one that has come out with the first solution here, and coined the term co-pilot. Really, I feel like, of course, AI has the ability to be a co-pilot for your life, as you mentioned, for many different aspects of your life. But one of the most exciting one for us, I think, as technical folks that have come from the cloud native world, is in the engineering discipline. And I think the generative AI can be used to enhance developer productivity in many different ways. One of the ways, of course, is in writing code, in making code more secure, in the entire DevOps process of, not just writing, but also reviewing and updating and checking in, and maybe even moving it to production. That's one aspect. The other aspect is running applications and detecting whether your application is running as it should, and maybe developing an idea of where it might fail, and when it does fail, what are the steps that need to be taken. So this whole planning of you know um, the uptime and maintenance of applications. This is another area where generative AI can have a huge impact, and it's just starting. There's not like well adopted solutions here, but there's a lot of innovation happening in sort of DevOps and kind of the SRE function, and I'm very excited about
Yeah,
that.
absolutely.
Um, yeah.
So on that note, I just want to share one of my recent experiments. So I took the standard logs that the Kubernetes control plane and kubelet emit, and I created a JSON-L data set with the commands to remediate, and I trained one of the LLMs. So basically, you throw an error that Kubernetes generates, and it comes back with the explanation and also the kubectl command to remediate. So it was fascinating to see how the SRE DevOps world meets LLM.
Yes.
So you're spot on. I think this is going to be disrupting the observability and SRE world altogether, all
Yes.
completely,
Yes.
from the ground up.
I think it's a very positive thing. I think it's a very positive change. It's going to be quite interesting to see what these agents can do, because these are areas where I think, a greater level of automation and intelligence could be quite valuable. Um, the other piece is, uh, aside from SRE and DevOps, I think generative AI has a role to play also in writing of applications. So right now we are getting snippets, code snippets, and you can give GPT-4 your code. It will tell you what the error is, or it will rewrite it. But again, going back to enterprises have lots of legacy code, lots of code that isn't running very efficiently, maybe isn't even possible to port to the cloud. No one is actually maintaining it. People don't know what it does, right? Think about generative AI's capability and potential in that environment, right? Where it's not cost effective to rewrite it ourselves. But what if you had a generative AI agent that could effectively rewrite that code, redesign that code in a way that would make it more efficient and scalable. I think that would be a huge value add. I remember when I was at NetApp, and our management software was, it was legacy and it was not scalable, and we had outages at our customers, and we had to take time, like we had to take a year to rewrite the platform. It was massive. It's so disruptive to our business, right? And that's why people don't do it. If something is working, okay, maybe we don't know how it works, but let it be, right? That's a lot of things in enterprise software. So I think generative AI, over the next couple of years, has the promise to really help modernize applications. So that's another. I think this is just like web technologies, right? It has broad applicability, wide ranging impact, not of course in our area of cloud native, but not only that, obviously. I mean, it's a very broad technology.
Awesome. So, Aparna, I can talk to you for another couple of hours because this is a very, very exciting area. And as the LLM ecosystem graduates and stabilizes, and as things change, I'm going to do a follow-up interview with you on how you are seeing this from the lens of an investor, but that's for another interview. So thanks so much for spending time with me and sharing your insights and the whole journey. We covered a wide spectrum of topics, all the way from your Stanford experience to your new way of working with Stanford from an LLM perspective. So it's been a wonderful discussion. Thank you so much.
Thank you. It was great to see you, Jani.